on this computer. All right, so we're going to be covering some more advanced Python concepts and kind of understanding how to use them and why you might be using them. And then hopefully you guys will be able to adopt these in your coding challenges going forward. Again, no requirement, just kind of good additional tools to know about. So we're going to be talking about Lambda functions first. So this is Python specific. Lambda functions. What are Lambda functions? So Lambda functions are essentially fat arrow functions from JavaScript. They're just called Lambda functions in Python. They're created when you want to kind of use a function in just like a very specific spot in your code, and you don't really want to explicitly create a function that's only going to be used in one place, right? So a function makes sense when you're going to reuse it, like call it multiple times. But if you're kind of just trying to do something quickly and you need a function on the spot, that's where Lambda functions come into play. These are functions that are nameless, as in they don't have an identifier. You can store them into a variable, but the functions themselves have no name. So you're gonna have here multiple variations of the same concept. So Lambda functions are also known as anonymous functions because they don't have a name. You might hear inline functions, function literals, and then obviously in JavaScript, we call them fat arrow functions. They're all the same concepts. It's just the idea of creating a function on the spot, using it, and then being done with it. Just some history, not that I don't really know much about lambda calculus, but the name lambda functions comes from lambda calculus. If we have any math majors in the audience, maybe they could explain lambda calculus to us, but I am not going to go down that road because I would fail miserably. Michael Robertson, you have a question?
My question is the fat arrow functions in JavaScript. Tom had mentioned in the course that they were trying to transition to using that instead of saying function. The locality of the lambda function that doesn't carry over to JavaScript, right? You can use the fat arrow and it'll be named in universal and all that stuff. Still correct?
Yeah, let's talk about that. So fat arrow functions are still anonymous functions in JavaScript, meaning they still don't have a name. And again, I know this is kind of confusing, but you can store an anonymous function in a variable, and that variable has a name. But that function itself is a nameless function. So, and it's kind of mincing words there, but again, variables obviously always have a name. Again, don't focus too much on the fact that these functions don't have a name. That's kind of just the derivation of anonymous functions. But the important thing to kind of take here is that it's a function that's created on the spot and then doesn't really exist outside of that scope.
Okay, I know that he had said that in JavaScript, they were kind of pushing people to stop using the function term and use the fat arrow kind of more universally. Is that still true? Or I just want to make sure that I'm on the right track.
Yeah, I'll yield to Tom on his expertise there. I'm not sure about the trends or whatever, but yeah, fat arrow functions are like the newer way to create functions. So I don't think people are outright saying you shouldn't use function keyword. I think fat arrow is just like a new trend, and especially in React, they are useful. So I would say, yeah, probably just get comfortable with fat arrow functions, but don't forget that the function keyword exists if you want to create a more traditional function declaration. Yeah, so we'll see these more in play. So again, lambda functions, fat arrow functions, same thing, just different languages. Fat arrow function in JavaScript, lambda functions in Python. Okay, so let's look at the syntax and usage of lambda functions. A little strange compared to JavaScript, but there's this lambda keyword. So if you want to define a lambda function, you have to use this lambda keyword. All right, so that's the keyword lambda. After that, you can specify parameters that you want to pass into your function. So X in this case is the parameter or the argument for my anonymous function. And then you have a colon, so that's just a delineator. And then after it, you have the return expression. Notice there's no return statement here. The lambda function automatically knows that whatever you have here is what you're going to return out of this function. So this lambda function is going to return X times 2, given an input of X. All right, and then as I mentioned, you could store them into variables. So I'm going to store this anonymous function in a variable called double func. I should be using snake case here, so that is my bad. Let me fix that before I forget. So we'll call it double func underscore because we are in Python. Oops. Okay. Hopefully I don't screw that more. All right, I screwed up my boxes. We'll go with that. All right, so double func is the name of my anonymous function. And then I could call that function as if I were calling any other function. So in this case, I'm calling double func, pass in 7, and we would expect 7 pass into this anonymous function. We multiply by 2, that's a return value. So if we did a print y, we should get a 14. All right, so it's basic usage of Lambda functions. Again, it's very similar, if not identical to fat arrow functions, just a little different syntax. A few more examples. Looks like I'm not using snake case. I'm not sure what I was doing here, but hopefully you guys can still buy that this is Python and not JavaScript. So a couple examples. So you can have no parameters. So if you have no parameters, you just use lambda : notice there's nothing between there, and just print or return whatever you want. In this case, this function is printing out something to the console. It's going to return none, right? So in this case, I'm taking in no parameters. I'm also returning nothing out of this function. This is the same case with a normal function or a traditional function. If you choose not to use the return keyword as in return nothing, the default return value is going to be none, which is a data type in Python. So no input, no output. So this will print a console, but there'll be no results returned. There'll actually be none. Like none is a data type. We have example 1 parameter. So I kind of highlighted these with colors. Lambda is keyword, orange is input. The cyan color is the return value. So this should return true because 8 is greater than 7. You can have multiple parameters. So in this case, we want A, B, and C. That's totally fine. Again, just like a normal function, you can have multiple parameters and use them at your will. So in this case, that should return 16. 2 plus 5 plus 9. Yeah, that should be 16. All right, just get used to that syntax. Again, you're not going to be forced to use this, but you might see it in someone else's code. Just to understand what Lambda functions are accomplishing here. All right, any questions about syntax, about anything Lambda function specific? All right, so again, if you see an opportunity to use this in your code, just give it a try, just to get familiar with the syntax in your challenges. All right, so why do you use them? Well, a few reasons. They're convenient. They don't clutter up your code. Again, they're just like on one line. You don't have to waste like extra space creating a function somewhere else and then only using it in one place, for example. There is some memory benefit of using anonymous functions. So I think going back to Michael's point, yes, you can store anonymous functions. For example, in this case, I'm storing my anonymous function in double func. So that's going to live in memory, as in that this Lambda function or this anonymous function is going to live for the duration of this application because I've stored it somewhere in memory. However, you can kind of just create a Lambda function, use it, and then it'll go away. And we'll see an example of that. So that's why it can save memory. So again, if you're really cognizant about memory performance, Lambda functions can kind of give you some benefit. For Python, there is a limitation. So this is a difference between JavaScript and Python. In JavaScript, fat arrow functions can be just like any other function. They could have a single line, they can have multiple lines, sky's the limit, right? In Python, Lambda functions can only have one expression. So you can only have one line of code in your Lambda function. So if you need multiple lines of code, well, you either can't use Lambda functions or you kind of get creative with how you use them. All right, so just keep that in mind. Only one expression can be used within a Lambda function, and that's going to be the return value. Okay, so Lambda functions, again, don't focus too much on them. As I said, that's not the highlight of this lecture. The highlight or the focal point are list methods. You're going to see these a lot. They're really convenient. You might be a little hesitant to use them, but I'm saying right now, get familiar with them. Use them any opportunity you see. Again, that's the best way to get familiar with these ideas. So there are 3 list methods that I want to highlight today. One's going to be map. There's going to be filter. Reduce, honestly, I have not used reduce that often in my coding challenges or anytime I'm kind of coding, but it is one that kind of gets used, so I want to add it in here. So map. What does map do? Map will take in a list and it will output a new list. And the key thing here is it's a brand new list. The original list is not being modified. All right, so just keep that in mind. So you can call map on an existing list. It's going to create a brand new list for you based on a mapping function. And we're going to see an example of this. So stay tuned. Filter, very similar to map. It's going to create a brand new list. Again, not modifying the original list, but it's going to use a filter function or a criteria function to determine what actually is going to go into the new list. Versus map is going to insert for every element that you have in your original list, there'll be an entry in the new list based on the original item. I know this is a lot of word soup, but we'll see an example and hopefully that'll clear things up. And then reduce will simply return one single value based on an aggregator function. So the easy example, like let's say you have a list with numbers in it, you can use reduce, pass in an aggregator function, which can kind of add up all the numbers together, or maybe you want to multiply all the numbers together, or you want to do something more crazy. Your aggregator function will basically accumulate all those values on how you determine you want to accumulate them. All right, so map, filter, reduce. Let's actually see some examples because that's probably gonna be way more clear. So let's go to our coding window. We're gonna create a new file. Let's call it list methods, and this is Python. All right, so the first one we talked about is map. All right, the map list function. So again, these are built-in methods that exist. And if you want to read documentation on them, there's documentation. So we do Python list methods. Again, we're only covering a few of them, but there's a lot more. You can, these are not the ones I want. Map, filter, reduce. All right. Python documentation. So map, again, you can read about it. The syntax for it takes in two parameters. One is the function that is actually going to map the original elements to the new elements, and then your input. So it looks like map takes in, let's see. Yeah, so in this case, your function goes first, and then whatever your input list is goes second. So if I want to use map, I will use, let's say, my list. Let's say that's 1, 3, 4, 5, whatever. Yeah, let's keep some 3s in there. All right, that's my list. And now if I want to create a new list, my new list based on the original list, I can use the map function. So my new list will equal map, right? So that's that map function. First parameter, again, reading documentation, is the function to apply. So I'm going to do this kind of the less, I guess, elegant way, and then we'll clean up later. So I'm going to create a function using the def keyword, and then we'll say, let's say double value. All right, this will take in a value and then simply return the double of it. So multiply by 2. All right, so a simple function called double value. Now my map function can take in double value as a parameter. Again, we're not calling the function. There's something hopefully everyone kind of understands. I'm not actually calling this function. I'm not passing anything to it. Therefore, when I pass it in here, I'm not invoking it. So that keyword I just dropped in there, invoking, means actually calling the function by adding the parentheses there. If I add the parentheses here, it's going to attempt to execute this code right away. I don't want to call this function. I just want to specify I'm passing a function to map that the map method can call when it needs to. All right, so therefore I'm going to do double value as my first parameter, and then my original list will be the second parameter. So what this is going to do is going to go through each element in my list. It's going to call double value for each element. So it's going to grab the 1, call double value with 1 as the input, and then it'll do the same for 3, 4, 6, 3, 7. For each element, my new list is going to have the same number of elements, but they're going to be modified potentially based on the mapping function. So if I ran this, I do a print my new list. So we should expect all these values to be doubled and printed out on line 10, or from line 10. So if I open my sandbox, I go to Python list methods. Okay, give that a run. It's not what I wanted, but I did not. Map. Oh, I need to convert that to a list. So notice when I did this the first time, you get a map object. I'm not actually sure what that is. I'm sure that has some properties and parameters, but you just want to take whatever that map object is, convert it to a list, because that's essentially what you want. So let's run that again. All right, there we go. So we got 2, 6, 8, 12, 6, 14. Is that what we expect? Well, double that. Yep, that's 2, 6, 8, 12. Yep, that looks like what I expected. All right, and then I'm going to take this moment to jump into JavaScript because JavaScript has a very similar method and they're kind of good to just cover together. So I'll go array methods.js. All right, so I'm going to attempt to do the same thing I was doing here, but we'll do it in JavaScript. So function return X. I'm going to modify this JavaScript quickly. Return that. This will be an array. This will be a new array. All right, so it's a little different in JavaScript. The map and filter and reduce functions are built into the array object. So instead of doing it this way, let me comment that out. We do a little different. So you do my new list. That's still your target. New array. And then on your original array, you're going to call a method. That method is called map, as you might have guessed. Map is going to take in 2 parameters. It's the same thing. It takes in, it takes in 1 parameter because you have your original list here. The parameter is a function. So let's say I want to pass a double function. Double value, I guess, is the name of our function.
I think you need a keyword to declare the variable.
Oh, yes. Thank you, Yevgeny. See, JavaScript, Python, always principal. Thank you. Yes, you're correct. So I want to create variables in JavaScript. I want my let keywords. Okay, so I get my original array. This is doing the same thing we're doing in Python. Maybe a side-by-side comparison would be helpful. Okay, so we have Python on the right side and JavaScript on the left side. So again, these are both doing the same thing. We have a function that's going to double some input value and return it. And then we're going to have our original lists. We're going to create a new list. So in Python, you call the map function versus in JavaScript, the map function is a existing pre-built-in method or function on arrays. So that's the difference there. All right, let me get rid of this bogus line. All right, so if we print my new array, it should be doubled as before. Save, and do node.
Console log.
Yes. Oh God, there's got to be some plugin that can kind of just auto create it for me, or maybe I should just implement the print function in JavaScript and just use that globally. That'd be much easier than me making mistakes all the time. All right, so node array methods. Notice we get the same exact thing, a little different coloring, but still get the same values: 2, 6, 8, 12, 6, 14. All right, so again, you're going to see this map function probably a lot more once you get to React when you're coding in JavaScript on the front end. So kind of get familiar with it. Don't shy away from it. All right, next we're going to talk about filter. And now, luckily, filter is very similar to map. So we'll do filter. We'll say bye-bye to JavaScript for now. Filter does the same thing. I'm actually going to use my original list. So my list is there. And let me just reassign it. All right, my list. And let's say we want to create my new list. We'll use the filter function. And that's going to take in a function again. So let's create another function here. Let's call it def odd values only. It's going to take an input of X, or again, whatever you want to name your variable. Let's say it's going to return X mod. Actually, let's just return multiples of 3. All right, so multiples of 3, that's going to mod it by 3 and check if it's equal to 0. All right, so the value is equally divisible by 3. It's going to return true, and this is returning a Boolean. So that's going to be actually specified. The filter function, your filter function should return a true or false. If it's a true, that means the element's going to be added to the new list. If you return false from your filter function, if it evaluates a false, then let me call that criteria function to distinguish. So sorry, this is my filter function that I'm using. I'm going to call this the criteria function that determines if something should be filtered in or out of my new array. So my criteria function will return true only if the given input is a multiple of 3. All right, so if I run this, I will pass in my function, multiples of 3 only, and then my input is my list. All right, so it's going to go through every element in my list, call my multiples of 3 only criteria function. If I get a true back from that input, then that element will be added to my new list. So can anyone guess what my new list should be printed out as? Any guesses?
3 and 6.
What was that?
3 and 6.
Yep. What exactly will be my new list?
I think
3,
it'll
6, and
be
3.
Yep, I think I heard it. 3, 6, and 3, because those are, we have 2 3s in there, so we'll get both of those. Again, it's not going to aggregate them. It's not like a set. Again, a set has unique values, but this is a list. So if I run, what is this? Python, and let's look list methods. There we go, 3, 6, 3. So our criteria function is kind of filtering out items that we want, hence the name filter. Here. Questions so far? Everyone understand the difference between map and filter and why you would use one or the other and why you would use map? So again, map is going to create a new list that's going to be based off the original elements and then modified by some manner depending on your mapping function. Filter, on the other hand, is going to filter out items based on your criteria filter. So the size of this list isn't necessarily going to equal the size of my original list, but for map, the size of both are always going to be equal if you use map. Okay, let's quickly do this in JavaScript. So I want to filter. I'm not going to copy code because I know I'll forget to convert stuff. So I'm going to type it again. Function, multiples of 3 only. It's going to be the same thing. Return x mod 3 equal to 0. And then again, same thing as with map. Filter is a built-in method off of an array. So you do, I'll keep that there. Let's do I'll just reassign my new array. My new array is now going to equal my array filter. Filter, and then do the same thing. So in this case, we just pass in the function, which is multiples of 3 only. And we should get the same output that we saw from our Python file. So do node array methods, and I don't want to print this out. Okay, notice we get, that's not what I wanted.
My new array.
Oh, thank you. Thought I'd go typo free, but apparently I can't. So we get 3, 6, 3 again. That's what my new array. I guess that was a good highlight. Let me actually print out the original just to prove it to you. My array. Your original array will not be modified. These are non-destructive methods, as in they're not going to alter the original array. So that's why these methods are really useful when you need to create copies or some related array. Okay, and the last one is reduce. This one, again, I don't use as much, so I might need to look up syntax. But again, the idea is you're going to aggregate something. So if I want find, let's just sum them up. That's a simple example, sum numbers. This actually takes in 2 parameters. One is, I believe, your aggregator comes first, and then your new value. So we'll call that X. And then you're going to return. Again, this depends how you want to aggregate. You don't always have to use the aggregator if you don't want to, but kind of the whole purpose of that is to keep appending to that aggregator. So if I do some numbers, I can do minus again. And then I actually think I need to import something. So let me look that up. Reduce Python.
import functools.
Thank you. So I need to import something because reduce is not readily available versus map and filter are. So I need to import, what did I just do there? I didn't copy properly. Import functools. Import functools. All right. So now that we have that, we should be able to use functools reduce. All right. So we have my list again, and let's just say let's total sum equals reduce some numbers and my list. Let's not let's. It is tough. I sympathize with you guys when you guys are doing challenges in JavaScript and Python. I am making that mix up quite often. All right, functools using reduce. Again, the goal of this is to add all these numbers together. And there's multiple ways to do this. Obviously, we could just use a for loop, right? All these methods can be achieved using a for loop. But again, the whole point is to kind of make your lives a little quicker, or your developer lives a little quicker, and kind of just make them a little more concise, your code a little concise. So if I ran this and print, because I'm in Python, total sum, let's see if I coded that up correctly. Python, list methods, 12. That is not 12, so let's read documentation. So reduce function sequence. How did I get 12 here? Let's get to the bugs. Let's check.
You're using my new list instead of my list.
You guys are good debuggers. Let's see that. All right, what should my output be? It should be 4 plus 4, 8, 14 plus 10. It should be 24 if this is all correct. All right, there we go, 24. So again, aggregator, this aggregator value is what's returned from the previous aggregation. So as we're going through my list, it's gonna get to 1. Aggregator is gonna be default to 0, and it's gonna add 1 to it. And then that 1 is gonna be returned for the next call. So when we get to this 3, the value of ag is gonna be 1. It's persisted. That's what reduce is doing.
I got a quick question. I know in JavaScript you can concatenate. Can you do it in with the Python?
Concatenate, as in you can concatenate this into one value?
No, I'm sorry. Concatenate your .filter, .map.
Good question. I mean, yeah, actually, I haven't really thought of that. So basically, the question is, if you want to call map and then filter it, I assume you just have to kind of nest them in one another. So I would take this. Yeah, it'd be kind of ugly. It is much more convenient in JavaScript, so I put this here. So I guess you can concatenate them that way. So in this case, we're going to call our map function, double all of our values, convert it back to a list, and then filter will filter multiples of 3. So yeah, it's a little less elegant, but can be possible. Okay, that's reduce. Very similar here. Is there a comment?
Yeah, I just had a question. Is it best practice to create a function outside of the list method, or can you just essentially just put the operation inside of the method?
Inside of like the map method, or
right,
like right here? Yes.
Yeah.
So that's an excellent
method.
point. Oh, sorry, say that again.
Or any method, not just filter, like any of these list methods.
Right. So that's where the whole idea of anonymous functions come into play. So that's why we went over Lambda functions before talking about these array functions or these list methods. So some numbers. All right, I'm not going to bother with reduce. Just take my word for it. It exists in JavaScript. Just trying to save some time here. So to Daniel's point, yes, we can kind of create the function on the spot, and that, lo and behold, is the whole magic of Lambda functions or anonymous functions or fat arrow functions, whatever you want to call them. So here I created a function. Let's say, this is the only place I'm using that double value function. It doesn't really make sense to kind of have this function exists for anyone else to use. It's kind of cluttering up my code because I only need it in this one spot. Well, yes, we can solve that easily via lambda function. So instead of doing this, we could do lambda. Input is going to be x. Output is going to be x times 2. And I feel like that's, then we get rid of this. This accomplishes the same exact thing, and I would argue is way more concise. It's kind of easy to kind of just read this. Let's read x. Lambda function, you create a function right here. When this line of code is done executing, this function is going to go away, as it'll be dropped out of your memory, so it's not kind of taking up space. Again, we're not too memory concerned here, but if you're writing an application that really had limited memory and need to manage this memory, this is probably a better approach because this will be used once and then dumped once this line executes. So that's, again, the whole reason why you might want to use lambda functions. Again, you don't have to, you can totally get away without using them. All right, we can do the same thing down here, multiples of 3, simple enough. We take lambda, we pass an x, and our return value is going to be x mod 3 equal to 0. Simple enough. Lambda functions. If you want to do it for aggregation, surprise, surprise, we can definitely do that. Lambda. We have 2 inputs this time, not just one. That's just something you got to know. With reading documentation, just know the function that you pass into reduce requires 2 inputs, not just 1. And then we want to return egg plus x. No, not return. We don't, so apparently the return keyword is actually going to be an error. I think they just want to make lambdas really concise, so you should not add a return keyword. This is going to be returned from your lambda function. Space is optional, but I like putting those extra spaces in there just because. All right, so that's a good use case of using lambda functions with these array methods or these list methods. Again, focus on map and filter. They are going to be used a lot, especially in JavaScript. So I think Matt brought this up, but yeah, it's much more convenient to chain them in JavaScript. So for example, let's say I want to double my values and then filter multiples of 3. So if I want to do both of those, I could do those pretty easily. Do my new array equals my original array, which is my array. Let's filter last, or sorry, we want to filter first. So we're going to map. Sorry, I'm switching my words. We want to double first, and then we want to filter those values. So I'll call map first, and then pass it my double func or double value. And then you could chain on a filter. So it's going to do the map first, and then it'll filter those values via multiples of 3. So if we do the math quickly, this will be 2. So this will be a multiple of 3. This will not. This will be a multiple of 3. I guess it's going to be 3 same values, just doubled. So if I do that, it should be 6, 12, 6 should be the output. So if we console log my new array. Let's node array methods. All right, we got 6, 12, 6 because there's no, what if we did triple value? I guess they all be multiples of 3 like that. If we made this multiples of like 4, that would change it. Okay. Okay, what questions do you guys have about using map or filter? Again, you can probably use it more in JavaScript. Again, this is very convenient. These functions, again, can be anonymous functions. So if I want to use anonymous functions here, I totally could and should, just to kind of make my code a little more concise. So I get rid of these functions. I could add them, I can still add anonymous functions here. So the shorthand syntax for that is that arrow functions will pass in a value of x, return a value of x times 2, and then multiples of 3, x and x mod 3. Okay, maybe a little less clear because we don't have variable names here, but looking at the code, it's pretty simple to see what's being done. But again, if you prefer having functions and the clarity of that, no harm done. Something I want to mention, since we were just talking about JavaScript, understanding anonymous functions. I think we might have gone over this before, or maybe not, but I just want to explicitly say it. So the shorthand, when you have only one expression, is you don't need a return statement. You don't need curly braces. You don't need anything else. However, if I want to do something else, like let's say I wanted to have a print statement here. Let's say I want to print out the value of X before I double it. I can't simply do this because now this is no longer a simplified function. So I need to wrap this in curly braces as if this were like any other function. So maybe clean this up, put this on a new line. All right, so curly braces are required when you have more than one item. Also, remember, just like any other function, you need the return keyword. All right, it's easy to forget, especially when you're going from a single line anonymous function. Again, there's no return keyword here, but it's implied, as in JavaScript knows that this is the return value because there's only one line. If you add more lines to your anonymous function, you need to add curly braces and you need to add the return value. All right, hopefully that will stick with you guys. Questions about list methods? Guillermo.
Could you just show us just a simple like arrow function without any of the methods?
Yeah, absolutely. So you just want to create an anonymous function. So let's do let's double value, stick with that function. So we do X times 2. All right, so we're creating an anonymous function. We're storing that anonymous function in a variable called double value. So if we ever want to use double value, we can simply do, console log, and then call this like any other function. So at this point, if I were looking at this code, like let's say we're all the way down here, and I saw this, I would not know if this is calling an anonymous function or actually calling a function like this. I mean, obviously I would have to look at the code and go, okay, this is a variable that's storing an anonymous function. But otherwise, all intents and purposes, you could use anonymous functions and functions the same way. Double value, let's double the value of 77. All right. So again, you're going to see the syntax, just understand it. It's okay if you're not comfortable with writing it, but understand kind of how to parse it and just know what that's doing. Okay, cool. If there's no other questions on, go for it.
Sure. The way you wrote it before, would it have returned 2 values, or would it have done one thing, then done the next thing?
You're talking about this example?
Yes.
Or are you talking about the entire chained example? Sorry.
Just the map part. I'm kind of a little bit confused. Are we printing X, and is that automatically has a built-in return?
No. So now this is just like another function. It's going to execute all the lines and return whatever you want to return. You can have multiple returns. So again, if you imagine just another function that existed, let's call it function blah X. This is the equivalent of doing this. Sorry, I did print again. Oh my gosh. I don't know how you guys manage this. I clearly can't. But yeah, that's the same thing. So now you just add more lines, so it's more like a traditional function. Yep, so again, not an implicit return, but you can have multiple returns in here. So I could do something like if X is equal to 4, return X times 3. If I wanted to just triple 4 for example. So again, you can have multiple returns. Again, the key here is curly braces lets you add more lines. If you don't want extra lines, you don't have to have curly braces. You can still do it. Like if I just have one line, this is the same thing as writing, create a new line here. That's the same exact thing as doing this, just without the return and without curly braces. And that can go on better. All right, cool. Great questions. I'm glad you guys are asking anything you guys aren't unclear about. So both these lines are the same exact thing, but notice one is way more concise than the other, just syntactically.
Ankur, if you have a fat arrow function that does not take an argument, do you just replace the first thing with a double parenthesis or with a parenthesis, or is that, I know that's not really applicable here with map and stuff because you've always got to return a value. But this is something I've been curious about. I see this syntax all the time and I get real confused about these fat arrow functions. Yep,
great question. I'm glad you asked it because I definitely omitted that. Yes, if you have no parameters, you need empty parentheses here. Parentheses here are optional, so you can add parentheses here just like a function call, right? When we have a function like blah, we have parentheses. If you only have if you have no parameters, yes, you have to have the parentheses there. Otherwise, you can have this. I believe if you have multiple parameters, you need to surround that. Yes, so if you have multiple parameters, you need to surround that with parentheses also. The only exception is when you have single parameter, you can omit them.
Thank you very much for that clarification.
Yep. So again, this looks really weird, right? Like if I were a new coder, I'd be like, what the hell is going on here? Basically, this is saying it's a function that takes in nothing and just automatically returns 4. That's all this function does. I don't know the use case for this function, but that is valid syntax. Okay, cool. Those are anonymous functions. Those are list methods. You'll see them from time to time, so just get better with them with practice. All right, a couple more items on our agenda. All right, ternary statements. I think we've talked about these before, especially in JavaScript. They do exist in Python, so I just wanted to cover that. We can write them pretty quickly, but let's look at a couple examples. So Python on top, JavaScript on bottom. This is the same ternary statement, just 2 different languages. So you have a true case. For Python, you put the true case first. In JavaScript, it comes after the condition. You have a condition, so that goes in the middle. I actually prefer JavaScript. I think that just makes more sense to me, but Python has done it this way for whatever reason. And then you have a false case. So essentially the same thing, just a few things swapped around. Notice the if and else keywords versus in JavaScript, you use question mark and colon. So again, just another way to be quicker about your development. You don't have to use these, but they can kind of make your code easier to parse and read. You can chain ternary statements. So next example, I've chained a bunch of ternary statements in Python. One thing you might be unfamiliar with, it's kind of a, I don't know if even trick is the word, but I have this backslash. This actually lets you create multiple lines in Python. Normally, you can't add a new line as you can in JavaScript, because JavaScript doesn't care about tabbing in new lines, right? The delimiter in JavaScript are semicolons. In Python, new lines and tabs are delimiters. So in this case, if you actually want something to wrap onto a new line just visually, you can use backslashes. Not prevalent use, so I only did this because I didn't have enough space, on my slide, but it totally works. So yeah, we could try to code this up in Python. Let's create a new file, ternary Python. All right, so I just want you guys to get familiar with the syntax. So the normal way, we just do if statements. So let's say x equals 9. Then we do if x greater than 5, prints return value. Yeah, so I guess this is one highlight of why ternaries might be useful. I need a variable, let's say output. Output equals greater than 5, else. All right, so in this case, I have a variable that I want to assign, but that variable depends on the value of x. So no matter what, it's going to be either one of these. I guess, there should be equal to here, but let's forget about that for now. This, I need 5 lines of code just to set the value of output. The better way to do it, or the quicker, less codey way, or less code blocky way is using ternaries. So in this case, the initial value here doesn't matter, right? Because it's always going to be assigned. So let's just use a ternary statement that says greater than 5 if x is greater than 5, else less than 5. All right, should be consistent with my capitalizations. Again, both are doing the same exact thing, but this is just one line. It's easy to read, takes up less space. I would probably prefer that. Again, depends on your use case. In this case, the initial value doesn't matter, so assigning it right away makes sense. And that's where a ternary operator is kind of useful. And if you go back to our talk about Lambda functions, remember that we can only have a single line expression in Lambda functions. So if you need to do if you needed to do an if statement in your Lambda function, a ternary would allow you to do that in one line versus you would not be able to do this in a Lambda function because that's more than one line. Questions about ternaries? We could chain them, as I said. So we'll make this greater than 10. Again, you don't need to have this backslash. I'm just doing that so I could wrap my line. Greater than 5, less than 5. All right, so again, they're just glorified if statements kind of using just a single line of code. Cool, you guys kind of cool with ternaries. Hopefully you guys have used them before. If not, you guys will start using them. In JavaScript, they can be chained also. So if you go to ternary JavaScript, same thing. So let's say let x equal 9.
On that last slide, or the last set of code there, are those essentially nested if statements? If I'm looking at it right, basically the else.
Yes.
The second ternary is inside of the first else, and then so on and so on.
Yeah, I think the way I format it's not the easiest to necessarily pick those parts out, but this is nested within. Let me format this maybe a little different. So.
Isn't that just a long chain of if else? I don't think that would be nested because then one of them would only execute if the previous condition was true.
Sorry, say that again, Guillermo.
To me, I guess the way that I understood it is that it's just a big chain of if else statements. Yes. I don't think they're nested. You can nest them, but those aren't, is my understanding.
Sorry, yes, they are chained. So yeah, we're doing effectively an elif and continuing that on.
That's what,
sorry, maybe I confused or said it.
You like can chain them a little bit inside like this comprehension, but that gets complicated.
Yeah. I just was confused because we didn't use elif.
Yeah.
So I was just trying to understand.
Gotcha. Yeah. In this case, you don't use elif because each of these. Let me try to highlight this in one line. I know it's going to be quite the long line. All right. So this is essentially a bunch of ternaries. This is not necessarily good code. So if you get to this point, you probably should break it up into if else's because it's not the easiest to read. But what's going on here? This is our true case for our first ternary. This entire thing is our false case. So basically, it's going to check x greater than 10. If that's true, it's going to use this. If x is not greater than 10, then it's going to check the rest of this. The rest of this happens to be another like a nested or I guess a chain ternary. So looking at this part, we go to greater than 5 is our true case. Everything I've listed here is the false case for this condition. Again, this is not good code. So I just want to say it's possible to chain them, but you shouldn't, if you get to this point, you're writing bad code, as in badly designed code. In JavaScript, it's a little more elegant. Again, I think I prefer JavaScript syntax for this. Usually I prefer Python for most things, but I think it's easier to read because you have your condition and then question mark, and then you can do greater than 10. I'm gonna code this up so we can just see it. And we have x less than 5. All right, so again, all the stuff I've done here is just formatting. It's optional. You don't have to put it on new lines. You don't have to tab these out. Again, this is JavaScript, so tabbing doesn't matter. Basically, the way I'd read this is, check the condition. If it's true, then execute the question mark part. If not, do the false part. In this case, it'll check this, and then if that's true, do this. I don't know if it's better to unindent, if that makes it clear. For me, I like tabbing them out. But anyway, you can chain them. That's a whole lesson here. I don't want to spend too much time on here. So let's proceed. Last thing I want to talk about are list comprehensions. This is, again, another advanced topic. What are comprehensions? It's a single line syntax, very similar to like ternaries, where you could use them on a single line to populate or create a data structure. Depending on use case, they can be faster than for loops. Background, it uses this underlying C programming language to kind of do the computation, so it's faster. Because again, Python's a high level language, C is a low level language, so it's generally faster. Also, using list comprehensions avoids having to reallocate your data structure in memory, and that's probably a whole lot of word vomit I just said that might not make sense, basically. But there's a way that arrays are stored in memory, and they're consecutive blocks. But if that block runs out of like enough space for new elements, it's got to relocate to a bigger neighborhood so that can store more members. Anyway, you can ignore that. We're going to have a data structure lecture in 2 weeks, so stay tuned for that. Understand that comprehensions can be used for lists, dictionaries, tuples, sets. I forgot a comma there. They can also be chained. So like ternaries, they can kind of be chained. They get kind of ugly, but they can be chained together. We're going to be specifically talking about list comprehensions, so that's probably the most often use case for them. Syntax and usage. So basically, you're creating an array. So you start with the square brackets and end with square brackets. Ultimately, the value you're going to insert, in this case, is x as the variable name. Again, you can name this whatever you want, but this has to match the second value, which is extracted. So if you kind of piecemeal this, you have a for loop that's basically getting values of x, and that x is being inserted into your list. You could also have a condition tagged on to your for loop. Again, this looks kind of strange. It takes a while to get used to. I'm constantly looking up documentation because I don't memorize, all the parts of it. But in this case, your list has an inserted value of x. It's extracting that value from this for loop, but that for loop has a condition. So in the first case, if we ran this, we would start our for loop. Our range starts at 6. We're incrementing by 2. So this is kind of like a lesson on range also. We start at 6. Our step is every 2. So we're going to start at 6. We're going to go to 8, 10, 12, 14, all the way up to 18, but not including 20. Again, 20 is not inclusive for range. So we'll have 6 through 18 even values. That's what my list is going to contain. If we did your list, it'd be the same thing starting at 6, but we'd only capture values that are greater than 9. So 6 would not be part of our your list. 8 would not be part of your list, but then 10, 12, 14, all the way up to 18 would be part of your list. So if you want to quickly code this up, just see it in play, let's do it. I'm going to call this list comprehensions. Okay, we had my list, and that was equal to, all right, so again, this can be done with for loops. You don't have to use the list comprehensions, but it just makes your code more concise. So if I did x for x in range 6, 22, again, this is going to basically go through this for loop, extract the values of x, and then store that into your list. So if I print this out, print my list, Python, list comprehensions. All right, there we go. We got 6, 8, all the even numbers, but not including 20. Because again, that 20, the ending part is not inclusive. If we want to change this to your list, we can. Your list just had an additional condition. Again, you can get kind of crazy with these, but so what this is going to do is execute this for loop, but check this value before returning it to the output. So basically, this should ignore the 8, the 6, and the 8. So if I print out for lists, notice the second list does not have the 6 and 8 because we added on a condition. Again, syntax is really weird. I know I'm not expecting you guys to memorize this or like be pros at it, just kind of understand what is capable with list comprehensions. As I mentioned, you can nest list comprehensions. So let's do, I don't know, their list. Let's say this is going to be a tuple. So we're going to do x, y. And remember, tuples are immutable objects. They don't have to be. I can make this a list if I want to, but I can use tuples for fun. We do for X in range of, let's go, keep it small, 4. So it's gonna go 0, 1, 2, 3, 4. Sorry, 0, 1, 2, 3, not including 4. But we also tack on 4, Y in, basically this is like nested for loops. So if I do range, let's make this smaller. Let's make that 3, let's make this 5. All right, so basically it's gonna, these are nested for loops. So this is gonna be run each time for each value of X. So if I ran this, let's see what the output would be. Print their list. All right, so we got this entire thing from that line of code. So notice we got all the zeros. For the first value of X is 0. We got 0, 1, 2, 3, and 4 for the Y values because we're going through a range of 5. And then for 1, we also have 0, 1, 2, 3, 4 from this for loop. Again, it can get kind of messy. I don't know if you're going to see this very often, but it is possible, is the whole point. As we said, we could use for loops and do the same thing. It's just more writing and more lines of code that you're going to be writing. So make this an empty list, do a for loop, X in range 3, or Y in range 5, their list, append tuple XY. All right, so same thing. Which one you prefer, it's up to you. One's more concise, both give you the same thing. All right, so again, don't worry about this. I know it's a lot of new information. Just wanted to show you some additional things in Python: list comprehensions, ternaries, and lambda functions. Use them if you are curious or if you get a chance to. But key takeaways, so just wrapping up this lecture. If you get nothing else out of this lecture, just understand map and filter, because those are the two most used array methods you're going to be using in JavaScript. You might use them in Python, but usually I've been using more in JavaScript just because I guess the type of development I do. Other items you mentioned, lambda functions, ternary statements, list comprehensions, know they exist. If you want to use them, great. If you don't want them, you can use for loops or whatever else, if statements to kind of substitute them. Okay, that was some advanced Python concepts and also sneaking in some JavaScript, talking about the map and filter functions, which exist in both languages. One last thing I want to do while we tie up our Python discussions, let's talk more about lists. This is something I omitted from the Wednesday lecture, so it's something I definitely want to cover. So I'm going to do that quickly here. So we talked about lists. Again, they're pretty much identical to arrays in JavaScript. My list, let's print some numbers. Whatever. So that's my list. Some special things you can do in in Python. That's again, just Python makes a lot of things really handy. There's something called slicing. So to get a value, we can do something like.
Are we able to take a quick break? Or are you almost?
Yeah, we're almost done. Let's take like 5 minutes. Okay. So yeah. Print. So let's just, if we want to extract a value, we use square brackets. So list index 3. What's this going to print out? Let's go with Seth Thomas. What is this going to print out?
Sorry, it'll print out 9.
Yep. 9 is the 4th item at index, sitting at the 3rd or index 3. So 0, 1, 2, 3. Yeah, that should print out 9. So that's square brackets, just extracting a value at index 3. But you can also slice. So slice is basically a subsection of a list. So let's do print my list. Oops. And so the slice syntax is you got to use the colon operator. So in this case, if I did something like this is actually going to do something a little different than what this is doing. This is specifying you're slicing this list. What this is doing is you're going to start at index 3 and capture everything after it. So if I printed this out, it's going to be starting at that 9 because that is index 3. And then it's going to basically print out everything after that 9 also. So if I did that, what is this? This is Python list.py. Notice we get everything after that. So slicing is similar to range, as in it can take in 1, 2, or 3 parameters. So if I wanted to, let's say, capture 9, 3, and 8, that'd be starting at index 3, ending at index 5, I guess. So I want to go to index 6. So this is non-inclusive. So again, 3, this is index 3, 4, 5, not including 6. So if I did that, we should get 9, 3, and 8. Yep, we get 9, 3, and 8. So again, just a handy way to get a subsection of a list. So again, the first parameter is where you want to start. The second one is where you want to end non-inclusive. And then there's also a third optional parameter. Let's say we want to go in reverse. So this would actually go through the sequence in backwards. And this is a little different than range. In that range, you need to swap these values. But watch what happens if I do this. This should print out, actually, what would this print out? This should print out 8, 3, 9, I believe. So let's validate that. Nope, we got nothing. Let me swap these. Oh, maybe I do need to swap them. Not bad. That's 4. Okay, so this is starting at index 6 and going backwards. So it's not going to include the 3. So starting at index 6 is 0, 1, 2, 3, 4, 5, 6. So it starts here, and we're going to go backwards. That's what the -1 is specifying, as in counter reverse. Okay, that's slicing for arrays. And the last thing, something special to Python. You can't do this in JavaScript. Let's say I want to get this value out of my list. Let's go with, what did I talk to today? Let's go with William Watson. How can I access this value? Via indexing.
How can I unmute Zoom? Okay, which value?
The last one here.
2, so my list -1.
Yeah, so I guess you got to my trick before I was trying to interest it, but yeah.
Sorry,
no,
my
fine.
list
0, 1, 2, 3, 4, 5, 6, 7. Yeah, so that's
one job. One.
No, I mean, I didn't specify how to index it, but yeah, you can do my list 7. Let's print that out. This, I had to count, how many items I had and get the last index. So I did that. But yes, in Python, as William smartly knew, there's a trick, or not even a trick, just syntax. If you do -1, that starts counting in reverse. -1 is referring to this index. It's the same thing as referencing index 7. So it's a little strange to have like a negative index, but just anytime you see a negative value, start at the very end and go backwards. There is no -0 because -0 is 0. So 0 is always going to be the first item. But if you do something like let's do -4. -4, you start here. This is -1, -2, -3, -4. So that should be this 3, which is the same as index 4 as it happens. So both of these should print out the value of 3.
Ankur, does doing this at all help out time complexity at all? Would it change the load on the memory with it?
I have no knowledge of that. I don't think it impacts lookup time because lookup time is constant for arrays. Okay. So I don't think there should be a difference, but yeah, just know if I go to index 3, that's the same as -5 because I have that many elements. So we print out 9 in either case, right? So we went forward, 0, 1, 2, 3, boom, or we went backwards, -1, -2, -3, -4, -5. All right, just some handy tricks. Again, Python is very developer friendly, so make use of it if you need to. Especially useful for getting that last element, which we often need.
Show them how to reverse the list so they can knock out the palindrome answer quick.
Sure, yeah, so we talked about slicing also. I guess I'm jumping back and forth between indexing and slicing, but you can copy a list very easily. So as we talked about in our previous lecture today, if I want my new list equals my list, this is not a copy. They're both pointing to the same exact thing. So if I did something like my new list dot append and I added a value of 10, both these are pointing to the same thing. So my original list is going to be modified. If you want to quickly copy something without having to do a for loop, the sneaky way is doing this. So you do square brackets and put a colon between them. This is slicing everything in this list. Since you don't specify a start value, it automatically starts at the beginning. since you don't specify an end value, it's automatically going to the end. So this will create a brand new copy in memory that you can modify. So now if you do it this way, when you append 10, it's only going to append it to your copy, not your original value. We talked about reverse, or someone mentioned reversing. It's kind of looks like silly syntax. If you do something like this, this lets you reverse a list. So this is basically slicing it and going in the opposite direction. No starting parameter, no ending parameter. So if we printed out my new list, print my new list, we should see this reverse. So 2 should be first, then 4, then 8. So let's verify that. There we go. Notice the gap flips. So it's kind of cool ways to do things. Again, there's other built-in methods like JavaScript, I think, has reverse for arrays, but this is kind of cool, foreign syntax, but kind of quick way to kind of reverse a list. All right, you can still put parameters in here. So like this would, get only a subsection in reverse 3 and 8. How did that happen? All right, I won't belabor it. All right, so yeah, we'll deserve a break. We've been going on for hours strong. So let's take a 12-minute break and then get into your Git pairs. Tom, I think you have the pairings, yes?
Yep, they should have been slapped out.
Gotcha. Yeah, so Tom selects them out in the Papa's channel. So take a look, get with your partner, attempt to do the Git pairing exercise first. And then today's not a pair programming day, so you can do the programming challenges individually, but if you want to stay in your pairs, I don't see any harm in that. But cool. So let me stop share, stop recording.